So there's a way that we can find limits at infinity a lot of times without going to a table or to look at even at the graph. So it's a nice little technique that we can utilize here to kind of put it on paper what these limits at infinity will be. And it all hinges on this, what I'm fixing to show you. Let's just think about some basic functions and the limits as x goes to infinity. I don't think this is a hard thing to understand. So if I've got the limit as x goes to infinity of 1 over x, limit as x goes to infinity of 1 over x. Well, one way I can look at it is I've got 1 and I'm dividing it by something that's getting bigger and bigger and bigger. So 1 divided by 10, 1 divided by 100, 1 divided by 1,000, 10,000, 1 divided by 10,000. It's getting smaller and smaller without getting negative. So what is this limit going to be? 0, isn't it? 1 divided by 1,000,000, 1 divided by 10 million. You're getting closer and closer to 0 there. So that limit's going to be 0. Same thing if I go to negative infinity. Is that going to matter? No, because your values are 1 divided by negative 10,000, 1 divided by negative 100,000, negative 1,000,000, 1 divided by negative 1,000,000. That's still getting closer and closer to 0. I mean, they're negative values, but they're getting closer and closer to 0. So in either case there, those limits are 0. Now, what if I change the number on top? Is that going to make a bit of difference? Let's make it a big number. X is still going to infinity. If I have a number here, like 1,000, I'm still dividing by x, and x is going to infinity. I mean, it may take a little bit longer, if you will, to get there, but that's still going to be 0, isn't it? Because you got 1,000, and this number is getting larger and larger and larger. 1,000,000, 10 million, 1 billion. It doesn't stop. It's still going to be 0, isn't it? That number is still getting closer and closer to 0. So the number on top, if it's a number on top, that really doesn't matter. Also, what if they've got a number, 5, and I've got x to a power, like x squared. That's still going to be 0, isn't it? Because essentially you've got 5 divided by infinity squared, so it's 5 divided by even larger numbers, in a sense. That's still 0, right? This little fact here will help us a long way, because if I have limit as x approaches infinity of any number, call it a, divided by x to any power, as long as the power is greater than 0. Because if it's a negative power, that's going to flip it up and it's not going to be in the denominator, you know what I'm saying? Any power of x, where that power is in the denominator and is positive, that's going to be 0 as x goes to infinity. Or limit as x goes to negative infinity, same deal. Any number divided by x to a power, that's going to be 0. Okay? Doesn't matter. So that little fact can help us quite a lot. All right? Essentially what we're saying here is if I've got a number divided by infinity, that's 0. Number divided by infinity, that's going to go to 0. If I can make that statement, number divided by infinity, that's going to 0. Okay? So how does that help? Well, that helps me evaluating these limits at infinity. let's say I've got the limit as x goes to infinity, 3x squared. Let's just start over. Progress here. So the limit as x goes to infinity, 3x squared minus x minus 2 over 5x squared plus 4x plus 1. So previously, if we came across a polynomial like this, we would say let's factor, but that's not the case when I'm going to infinity. That's if x goes to a number. I look at trying to factor it if it goes to 0 over 0. But if x goes to infinity, it's a whole nother technique. That's, first of all, key why I'm doing this. So here's the technique. What I'm going to do is I'm going to look at the denominator and say, well, what's my largest power of my denominator? Well, it's x squared. I mean, there's x squared at the top, but that, in a sense, doesn't matter for this technique. It just so happens that it's the same, but it's the largest power in the denominator. So I'm going to divide by the largest power in the denominator. Divide the denominator. So I'm going to divide the denominator by x squared. Well, if I divide the denominator by x squared, I better divide the numerator by x squared. Otherwise, I'm changing this up. So I'm going to divide the numerator and denominator by x squared because it's the largest power in the denominator. That's why I chose x squared. Okay. All right. Well, here's what that means. What that means is I'm going to divide the whole thing by x squared, each term by x squared. So I'm going to divide 3x squared, divide that by x squared, minus x, divide that by x squared, minus 2, divide that by x squared. So everything on top I divide by x squared. Same thing on the bottom, divide everything in the bottom by x squared. So I'm writing it out this time. You can probably save a little time here next time, but that's what this does. Now if we simplify that, that gives me the limit as x goes to infinity. The x squareds cancel out, so that's just 3. Now what happens here? X divided by x squared. Well, the x goes into one of those. It leaves me 1 over x. Right? There'd be an x still left in that denominator. And then, of course, that doesn't simplify at all. With me there? So I just simplify the numerator, simplify the denominator, same thing about happens. The x squareds cancel there. That x goes into one of those and leaves me 4 over x plus 1 over x squared. We're almost there. Now, this is why this pays off, because look at what, on limits, pretty much everything goes. We just do the limits of these all individually. I do the limit of that, minus the limit of that, minus the limit of that. You know what I'm saying? I'm not going to write all that out, but that's what I'm doing. What is the limit as x goes to infinity right here? Isn't that 1 over infinity? That's our 0, isn't it? This goes to 0. As x goes to infinity, this goes to 0. This goes to 0, and that goes to 0. So here's what I've got. I've got 3 minus 0 over 5 plus 0 plus 0. I've got this figured out, don't I? It's 3/5. That's my limit as x goes to infinity. It's 3/5. Okay? All right, try another one. Let's try the limit as x goes to negative infinity this time. And it's x squared minus 3 over x cubed plus 4x plus 3. Well, as x goes to negative infinity, you're going to do the same technique. It doesn't matter infinity or negative infinity, what x goes to. Do the same technique. So I'm going to look at the denominator, largest power in the denominator, x cubed. So I'm going to divide top and bottom by x cubed. Well, kind of shorten this. What happens if I do x squared divided by x cubed? What's that going to give me? 1 over x. If I do 3 divided by x cubed, that's going to give me minus 3 over x cubed, right? Just to cut a little bit of this out. With me there? So far so good? All right, now x cubed divided by that's 1. 4x divided by x cubed, that's 4 over x squared. And then 3 over x cubed is 3 over x cubed. Yes? So you already got that. Now what happens? Well, as x goes to negative infinity, same thing happens as positive infinity with these 1 over x's or number over x's. Those go to 0. This goes to 0, this goes to 0, this goes to 0, this goes to 0. So I've got 0 minus 0 over 1 plus 0 plus 0. What have I got? 0 over 1? 0. That's how you get these limits at infinity using a little, I guess we call that algebra. Probably never did that in algebra, but that's what we did. Okay. All right, a couple more. How about the limit as x goes to negative infinity, x to the 5th minus x cubed over x to the 4th plus 2x squared minus 7. What am I going to divide this one top and bottom by? It's a little tricky. It's not the largest power of x, is it? What's the largest power of x in the denominator? X to the 4th. There's a larger power of x on top, but it's this technique, you only do the largest power in the denominator. Okay? So I'm going to divide by x to the 4th here. Even though there's a larger power in the numerator, I still just divide by x to the 4th. So that's the limit as x goes to negative infinity. Now, x to the 5th divided by x to the 4th. It's not 1 over x, is it? It's x over 1, or x. That's x. X cubed divided by x to the 4th. That's 1 over x. So on top, when I do this, I've got x minus 1 over x. Yes? On the bottom, that divided by x to the 4th is 1. 2x squared divided by x to the 4th, that's 2 over x squared. And then minus 7 over x to the 4th. So I've got some zeros. Number over x, that goes to 0. So this goes to 0, this goes to 0, this goes to 0. Now this is a little different, isn't it? Because now, here's what I've got. So leave this for a second. So I've got that's minus 0, that's plus 1 plus 0 plus minus 0. So what about that? Well, that's x. And x goes to negative infinity. Well, let's put that in here. I mean, that may not be the most correct thing to do, but I think it makes the point here. So I've got something that goes to minus infinity, minus 0, of course that's gone, and the bottom is 1. So essentially what I've got here is minus infinity divided by 1. What's that going to be? Well, this is minus infinity divided by 1. That's minus infinity. This one goes to minus infinity. It doesn't have a number value. It's minus infinity. Okay? All right. And this one's similar, I guess, but you know, you just have to work out the signs if you get something like that. X goes to minus infinity, x to the fourth minus 16 over x squared plus 5. So it's the same deal. I've got a larger power, but the largest power in the denominator is x squared. So let's divide top and bottom by x squared. So that's the limit as x goes to negative infinity. Now x to the fourth divided by x squared is x squared. And then minus 16 over x squared. X squared divided by x squared is 1, and 5 over x squared. So this is 0, this is 0, so I've got x squared. So here I've got negative infinity, the x is negative infinity, squared minus 0 over 1 plus 0. So what's going to happen when I square the negative infinity? Well, it's a negative times a negative still, isn't it? It's not going to still be negative infinity though, is it? It's a negative times a negative. It's a positive. This is positive infinity. If I square negative infinity, that's positive infinity. So that one, like I said, you just got to play with the signs. If I had negative infinity divided by negative 5, that's a negative divided by negative, so that's also going to be positive. You see what I'm saying? You just have to do, you know, the sign rules still apply there. A negative divided by a negative is still positive. A negative squared is still positive. Okay? All right. One last problem, then we'll do some others next time. What is the horizontal asymptote for f of x equals x minus x squared over 9x squared minus 1? What's the horizontal asymptote for that? Horizontal asymptote. Yeah, horizontal asymptote. Well, this is the same version of the problems we were just doing, asking a little differently, because remember, the equations of the horizontal asymptotes were what? It was y equals L, right? It was what happened as x goes to infinity, or negative infinity. Either it's going to go to the same number. So this is asking, what's the limit as f of x as x goes to infinity, or minus infinity? It'll be the same. You're not going to get a different number on this one. So that's how we're going to find these horizontal asymptotes. Okay. Do the limit as x goes to infinity. Like I said, it doesn't really matter, positive or negative infinity, of this expression. You with me there? And so, whatever that comes out to be, y equals that. That's the horizontal asymptote. So it's the same deal. So here I divide by x squared. So that gives me the limit as x goes to infinity. 1 over x minus 1 over 9 minus 1 over x squared. So that's 0 minus 1 over 9 minus 0. It's negative 1/9. That's the limit. And so the horizontal asymptote then is y equals that. Okay? That's where it levels off. Like I said, what would change if I did negative infinity? Not a thing. I would still get the same answer, so it doesn't matter if I went to negative infinity, the same thing. I think it also asks you here, is that okay? It also asks you here about the vertical asymptotes. And this is kind of review, I guess. I hope it's a review. How do we get those vertical asymptotes? It's a little different, isn't it? The vertical asymptotes you find from a function such as this by setting the denominator equals 0. find the vertical asymptotes on one like this. Yeah, denominator equals 0. I was just, unless it cancels out or something. Something cancels out. Yeah, so you're just going to do 9x squared minus 1 equals 0. Solve that. Denominator equals 0. Let's see, that would be add 1, so we have 9x squared equals 1, divide by 9. So that's x squared equals 1/9. That'd be x equals positive or negative the square root of 1/9. So that's positive, negative 1/3. So the vertical asymptotes would be x equals 1/3 and x equals negative 1/3. So if it asks for those, that's how you do those. Question?